Good morning, all. Can you guys hear me?
Yes, I can hear you loud and clear.
All right, thank you. For the participants, I hope you have installed the software. If you haven't done so, you may download the software from your email attachment. Or you may follow this link. I will send it in the chat window. The file is only like 27 MB, so you download the file and then you install it. The installation is very simple. You just click install and then you wait for the installation to finish. And then you may find the application in your program file. And good morning to all participants. Thank you for finding time and visiting today's structured course entitled Graph Grapper Workshop Data Extraction from Journal Articles and Thesis. And the workshop will begin shortly, so please ready yourself and kindly keep your microphone muted to avoid any interruption to the presentation. And if you have any questions during the presentation, you may type in the chat window. And keep your video turned off until the group photo session at the end of the course. And for UTM students, you will be given an e-certificate and UTM merit in the ARCAD system if you fill in the feedback form, which will be given near the end of the session. And the feedback form will be used to record your attendance and for us to send you the certificate and the slide. So be sure to enter the correct details. And while we're getting ready and waiting for some more participants to join, and we expect the workshop to start within 5 minutes at 10:30 a.m. And meanwhile, you may use the time to download the software and install the Graph Grapper software. So see you in 5 minutes. So good morning to all participants. Welcome to Postgraduate Structured Course organized by Postgraduate Student Society of Student of School of Electrical Engineering. My name is Sim Man Seng and I am the moderator for hosting the session today. And I'm glad to welcome Associate Professor TSIR Dr. Michael Tan Long Peng, who will present Graph Grabber workshop, data extraction from journal articles and thesis. A little bit of introduction on our speaker. Dr. Michael Tan Long Peng is an associate professor in the field of low-dimensional nanoelectronics devices. He is the head of Computational Nanoelectronics Research Group, School of Electrical Engineering, University Technology, Malaysia. He obtained his Bachelor of Engineering and was appointed as a tutor in the same university in September 2003. He started his master by research on June 2004 and carried out his research as a graduate intern in Penang Design Center, Intel Technology, Sendirian Berhad, Penang. He was awarded Masters of Engineering from UTM in 2006. Subsequently, he pursued his PhD in engineering at Queen's College, Cambridge, from October 2007 until June 2011. He was awarded his PhD degree in July 2011 at the University of Cambridge, United Kingdom. He is a chartered engineer registered under the Engineering Council, United Kingdom. He is a lifetime corporate member of the Institution of Engineers Malaysia, member of the Institution of Engineering and Technology, and senior member of IEEE. He is also a professional engineer and a professional technologist. His research interests are in device modeling and circuit simulation of low-dimensional nanostructures. Okay, so that's the introduction of our speaker. So, Doctor, you may share the slide, and whenever you are ready, you may start the presentation. Doctor? Yeah, I will pass the mic to Doctor.
Are we going to start now, Manseng?
Yeah, I think we can start now.
Okay, let me share my screen first. I got many things to see.
All right.
Let me share a few. Need to share a lot of things. Share content, Excel. The editor. Now you can see my editor, and then the last one is my PDF. All right, so we begin with my PowerPoint. Everybody can see it clear? Okay.
Yeah, we can see it clear.
All right, so good morning, everyone. I'd like to thank again PGSS SKE for inviting me to do this talk on digitizing your data. So one of the things as a researcher, postgraduate student, as well as a lecturer, we want to get data from journal paper to benchmark or to compare with our model. So that is why it's important to get the data. All right, so how do we get the data from journal paper from outside? So I'm going to show you a software that I just found recently. Before that, I found many digitizing software that you can use to do that. Some of it you have to pay yourself, but I just found this one, which is quite good. They can do the extraction for you automatically. You can do it manually, and it is free. All right, so what is actually a digitizing software? It converts an image file showing a graph of a map into numbers. So that is it. So for the type of graph that you normally can digitize is the normal X and Y scatter plot, that kind of graph. If you want a complicated graph, something like in communication like that, it's not really feasible. You cannot do that. So it's actually normal graph, the one with the X and Y, some plot like that, scatter plot. This is suitable for it. So the image can come from a scanner, digital camera, or screenshot. The numbers can be read on the screen and written or copied to a spreadsheet. So what it means here is that once you get the data, you digitize it, you get X and Y, you can export it as a CSV file, which is in spreadsheet, Excel file. You can open in Excel, all right, and you can plot it. But usually for my PhD student, they will normally plot it in MATLAB. So you can take the CSV file, open MATLAB, import the file in, and you can plot. So I will show you step by step how to do that from the PDF. You're going to get the X and Y. We create a CSV file. This CSV file you can open in Excel, or if you want enhanced plot, you can open in MATLAB. So why would you need this tool? You are an engineer with some graph, but you really need the numbers represented in those graphs so you can do further analysis. Okay, so what else? You are a graduate student gathering historical data from charts for your thesis. You need to get experiment data. So this is normally the case that we face. We want to get data from other sources, from other researcher. So that we can do analysis and we can compare with our model. So that is called benchmarking. What is that? The validation. Okay, you would like to benchmark your findings with published data. So here another real life example. You ride a bike or boat and want to know how much distance you're covered in your last trip, but you do not have an odometer or GPS unit. However, you do have a map. So you can actually scan the map and you can do it manually. You can get the distance using this software. So there are many examples you can do. So let's say that this is how I do it. This is actually a paper from University of Cambridge. This is all my colleague at that time. So let's look at this graph. First of all, I would say that you want to identify a figure from the paper. And I saw the question just now said, how do we actually get this graph into the software? Well, you have to use a print screen. A normal print screen will do. In a function in your computer laptop, you just press a print screen and you get the graph. Okay, once you get this print screen, the next thing you do, you get something clean like this. Print screen, you get the graph, you can see, okay, This is what the graph that I meant with scatter plot. We have a lot of data. We got 4, 1, 2, 3, 4, 5. We got 5 legend here, 1, 2, 3, 4, 5 legend. And we got multiple VDS. These are the graph. And imagine if you look at the graph, right? The first thing you look at is actually a lot of it. And then at the end, they start to jump. You see that, oh, it's jumping up and down here. So if you were to do it manually, you can. You just have to click many times using your mouse. You click, 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 and you can do it until the end. Or you can use this auto function that I will show you later on. You just mark it or shadow it, and you click enter, and you'll get it. Obviously, you'll find some of the plots will not be perfectly matched with this scatter plot, but you can adjust them. You can just bring your mouse there, you can adjust it, put it below or after to fit it accurately. And if you wish to add more plots, you say that, oh, they missed this plot here, you want to add one more plots or one more dots, you can do it. You can do that using that software. So let's look at the software here. First of all, I'll just explain to you how to do it using this PowerPoint. And after this is done, we'll do it together. I'll just open the software and show it step by step. Okay, now we just follow, you just look at it first. This is the software called GraphGrabber 2.0.2. Unfortunately, it doesn't work in Macintosh. It only works in Windows. If you want to find other software that work in Mac, you can. There are a lot of software out there. You can just Google type digitizing software or digitizer. You can find other software that is suitable for Mac. But I would prefer this one because it is free and there is a lot of feature I can do with it. The first thing you do is that you open an image from file or open image from clipboard. If you already print screen earlier on, you can just say open image from clipboard. But if you haven't done that, if you already save it as a JPEG file, you can open image from file. So for example, like this, you open the image, you get this image, and you see that this image doesn't fit the screen because you see that some of the plots, you cannot really see it that well. You press this function called fit image to pane. So you see everything nicely, nice and clear. Okay. So the next thing you do is after you fit it, is you have to set your X and Y. And it's so easy. You can do it finish in 5 minutes. Okay, set X and Y. So the first thing you do is you set X and Y. You see that your X, the minimum is -10 to 10. So you press your set X and Y, you get 10 to 10, -10 to 10. And you select linear. Okay, it's easy lah. You didn't see the arrow here because when I press this axis, the arrow will appear. So I just drag the arrow. You see -10 to 10. You can see some arrow here. Okay, done. You press OK. Then you repeat for the next. You get for the y-axis. Okay, y-axis. There's something you have to pay close attention to here. Is that it is 1e -13 and 1e -5. Then you have to select log. Okay, it is not linear, so it is in log. Because it's -13 to -5, you say 1e minus 13, 1e minus 5, you select log and you say OK. Okay, select log scale along y-axis, you get it, done. And you're done. Okay, you already got the value and you can do it. Well, first example, I'll show you, you do it manually. So you say add data series manually. Okay, you press that and what do you do? You start clicking. You can see, right? There is some red square here, red fill square over there. I'm just starting to click, follow the line, click, 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 click. How many times you want to click? If you did any mistake, you just delete the data point and you start again. You just delete one data point is good enough. Okay, you just click. Okay, and you're done. You already got the data. So how do you know you already done? You got the data. You say you click to end the series. Okay, click to end the series. And if I want to change the name or anything, I can do, this is all called the enhancement. You can do later, change name. Then in that software itself, when you click the next step, the graph data, this is the data you already got. Right? From previously, -10 to 10 and 1e13 to 1e5, you already got the data on the spot. You can see it here. And then even if you want to use it here, you want to save it as a figure, you can do that, or you can export it as a CSV file. So the next thing what we do, we export the data as a data file. We want to get the data because we do not want to plot it inside that software. We want to plot it in MATLAB. That's what you do. Export graph as a data file. And you name it. You name your file. Experiment underscore data.csv. I'm getting this file now. Okay. The next is you want to plot it in MATLAB. Okay, plot it in MATLAB. What do you do? So a very simple, import CSV and Semilog plot graph in MATLAB. These are the codes. Clear all, close all CLC, which means that you clear all the workspace, close all the figure that you have, and clear the screen. Very simple. You see, read table experimental underscore data.csv. You're going to read the file, and then you change it to array because once it goes here, it's a table. It's not a double. So you change it to array, and you just say semilog. The first, this is called the x-axis, and this is the y. And you got the graph in MATLAB. Obviously, simple code means simple plot. If you want to have beautiful graph, more enhancement, so the script you have to write longer. So that's what I did later on. So this is normal n file, normal plots, read table, table to array, semilog, you get that. But what if you get this simple graph lah? There is no y-axis, x-axis, and there's no labeling lah. This is a simple one. But if you write more, so last time what I used to teach is that I teach MATLAB courses and I teach students how to plot high quality graph for journal paper and thesis. And then one of my PhD student, Moven, he's very good at this coding as well. So these are the coding that we use. So this example, if you do not know MATLAB, perhaps in the future we'll do another course on MATLAB, how to do the plotting. So this is the same thing. If you look from over here, read table and then table to array. And the next thing we do is that we're going to set the font size. We're going to change the line width, the font width, normal font size, and all these things here, labeling. And you see what happened. Look at it now. With just a few lines that you added, you're going to get a beautiful graph like this. Source data, current A, get voltages over there, you get experiment data. But what else can you do? This is one of the examples that I show you. This is one of the enhanced plot. If you want to do a lot more, yes, I just add this one line here. This is called interpolation. Interpolation, which means that if you look at the previous graph, and it depends on how I click. All right. Sometimes if I click, the distance is too far away because it's based on manual clicking. You see that some distance there are no data. All right, there's empty data here, there's some empty data here. So I just put a statement say that interpolation, which means that the graph just now make it sure that there is no gap. Make sure that every plot, every line, we have more dots. There's there. Just a simple line. You see this straight curve now. All the dots are here. Very nice, very clear. And that's how you can do it. Don't worry, we will share all the thing for you. I'll just give you everything in the M file. If you want, I'll share this M file, I'll share the M file. You look at this graph right now, we just one line added there, you get a very beautiful now, high quality rates from the journal paper. Okay, so what are the bonus feature by using this software? What can you do? These are the more features there. So looking back to add data series automatically. We want to do automatically. Can it do it or not? All right. Okay, so you look at this example. Previously, I've done manually for the red dots, for the pink here. So we want to do the second one automatically. So what you do, you just say add data series automatically. Then they'll ask you, you want to do a masking, mask. Do you want a thin mask, medium mask, or thick mask? Then I'll say, okay, I'll use the thin mask. You see what I did here? I just shade it. I just move it around here, move it up and down. Just move it as simple as that. When you're done, you say click when the mask is complete. GrabGrabber will now create series based upon your mask. Would you like to continue? Say yes, no, continue mask, or cancel. Say yes. See, when you just click there, you see what happened. It automatically get all the blue dots right now for you. Okay. Next, they say that you can change the threshold, higher threshold or lower threshold, which means that sometimes it doesn't accurately mask it correctly. Do you want to increase the sensitivity or you want to reduce the sensitivity, something like the threshold here. So you can adjust, you see how until it fits, you're happy with it, you say apply and you accept. And the next thing you do, you can even select you want more points or less point. You move it around here, you're done here, accept. And if you look at the graph data view now, you can even plot two graphs right now. So you already got the data. And I can assure you, if you're as good, you can just finish this less than 5 minutes. It's as simple as that, because most students or most people that do not know how to use digitizing, they say it's extremely difficult. Even last time when I did not know about this software, what I did was I take a ruler, I print it out myself. I take a ruler, I put the centimeter. I say, okay, this first dot, 2 cm, 3 cm, 4 cm. I do it manually and I put in Excel. That was like perhaps like 15 or 20 years ago. But now you don't have to do that. By using simple software as this, you can get your graph easily. Obviously, there are many digitizing software out there. All right, some of it you need to pay, some of it are free. And I found that some of the software that you have to pay, they do not provide features automatically, features like this. Okay, it depends on you, but I do recommend this Graph Data Grabber. If you are using Mac and if you really want to use this, maybe you can install something that can run Windows application on your laptop. Okay, so that is it for my presentation, and we'll go to do hands-on right now. Okay, so before I go hands-on, is there any question? I can't really see the chat. Okay, if it's any question or not. All right. Okay. No question. Let me see. Okay. Before we move on to the next one, how accurate is the data? Oh, the data is okay. You want to ask how accurate is the data? Yeah. If you can click as precise as you can, then you'll be as accurate lah. But I can say that it is how you click it. All right. If you want super precise, you do it manually. If you feel that you allow some variation, error margin, then you can use the automatic features. Okay. I can tell you that you don't have to be so accurate. All right. As long as it's just a bit slight up and down, it's okay. All right, because I'm doing experimental. Okay, let me show you some journal paper. So these are the journal paper that I've completed when I finished my PhD, and I'm going to show you some example. Right, some example. How do I plot my graph? And this is plot by using MATLAB. Just now I show you the software, and you can see that some of the red dots over here versus experiment data. I say these are the experiment data that I use another digitizing software many years ago, and I compare with my model, which is the line there. You can see the line and the dotted, and that's how you can do it. Okay, just move some around. And it is very important when you provide graph to journal, when you're publishing paper, to make it high quality and high resolution. So many students, right, when they make graph, they do not know the correct method to do it. They just maybe save it as JPEG file and then they attach it in their Word. That is not the right way to do it. Usually when I use MATLAB, I use another features. I copy the figure. I don't create JPEG file. I paste it. Then when I normally ask student always ask me okay, how do you know the graph is high quality and high resolution? All right, let's look at the resolution right now, right? I'm zooming at 200, right? Okay, I'm zooming closely. See, I'm zooming at 6,400 percentage. And look at the graph. Look at it. Is it super crisp and clear? Look at it, it's super clear. So that is how you say it is a high quality graph, which means that once you zoom, everything is super sharp and clear. And you can get it by using MATLAB. All right, by using MATLAB, you can get super clear graph. And let's look at my other figures. Okay, This is also using MATLAB. A good thing about this curve is that I do an inset, which means that inside the figure, there's another figure. Okay, like inception, a dream within a dream. So this figure inside a figure, and let's zoom the mouse back. Let's zoom it. Is it clear enough? It's super clear. Look at that. Look at this. All right. Perhaps if you want to know how to plot this, perhaps next course lah, because you're not really focusing on how to make as clear as this. I'll show you some example only later on. And these are my experiment data that I got from journal paper, and you can look at the dot. And I told you that in my MATLAB script just now, I got this function called interpolation, which means that there is always a data point. And look at that. There is no like something like missing here, like an empty missing here. It doesn't look good. So every time there's a data plot here. Okay. Get that. Okay lah. All right. This is not using MATLAB. Okay. When you're not using MATLAB, this is what you get lah. When you say about high quality curve, you're not gonna get a super clear one. So when you zoom so much, you can see this very blurry. There's a pixelation that happens here. Okay. Okay, let's look at the other paper. Okay, this is also another paper that we did. Let's look at the graph. Okay, this is by using, look at that, clear, sharp and clear. So, oh, look at that, complicated, so many experiment data. We represent it by a triangle plus asterisk, all those lines here. All right, enough for this journal paper. Let's start right now. How do we use this software? Okay, let's start it here. First thing you do, you open the software, and then perhaps you want to know how do I get the graph. Let's look back to here, my digitizing software. Let me find the paper. Sending paper. Okay. So you can see this is the carbon nanotube Schottky diode and directionally dependent field effect transistor using asymmetrical contact. Let's scroll down here. So I have a question just now. How do we get this graph? You want to get this graph, right? Just press print screen. You look at my software, right? Can you see my software? Can you see this? I'm dragging it right now. And I already got the graph. Not too sure if you can see this or not. Let me share. Snagit editor. All right. You are able to look at this right there. By I'm using a software called Snagit. All right. If you're not using some software called Snagit, you can use other software in Windows as well. You got this graph here. Then you ask, do I need to remove this or not? Do you need to remove this figure here? You do not have to remove it. You do not have to remove it. If you say, if I don't remove it, will something happen to the when you're grabbing the data? No, nothing will happen, right? But because in my PowerPoint, I remove it because I don't want that to distract you. But if you don't remove it, it is okay. Okay, you already got this thing. You can say Control C, Control C, let's play Control C. And you go grab data. You say that I'm gonna open image from there. Open image from clip data because I just clicked just now. I say I already copy it. I paste it here. Can we use crop features in Adobe PDF to get the image? I haven't used the crop feature in Adobe PDF, but as long as you can crop something up, it is okay. Even if you crop it up, you save it as JPEG, it works as well. All right, as long as you can crop it, I believe you can put it in this software because it's just loading an image. Okay, you already got this. The next thing you do is you have to set your axis, X and Y axis. And how do you do that? How do you get your axis? You just set X axis. Can you see here? You see, I'm dragging here. I'm dragging. I have to click first. Click here. Okay, again. Click. Can you see this arrow? This arrow shows where is the end point because I click on the start. I'm going to the end point here and click there. and I say negative 10 to 10. That's all. Negative 10 to 10. Okay. All right. So it's store. Now we do the Y. We click here, click one time. All right. You see, it's moving here. It's moving there. And we put it on top here. And this is how you write it, because I saw many mistakes. Student write it 10E 13. No, it's not 10E 13. You only see my PDF. You're not seeing the software. Oh, I thought I already put the software. Sorry. I'll start again. Yeah, sorry. I didn't know. You didn't look. You didn't see it. Let me start again. Open. All right. Open image from file. I hope you can see it right now. Open image from clipboard. This is the file just now. Okay, you get the file. Okay, fit image to pane so you can see everything clearly. All right, I can see everything clearly. This is the graph I got. Okay, I'm happy with it. All right, next, first thing you do, the x-axis. Okay, x-axis, you click on here. Then there's a plus sign here. The plus sign, I'm moving it here. You can see it. I'm clicking here, negative 10. You can see there's an arrow right now, right? So say, where's your maximum value for your x? Where's your maximum value? Maximum value is over here. Just click it. You're done. And then what's the minimum maximum? Negative 10 to 10. Negative 10 to 10. And you're done. You click OK. You're already done. X-axis, you can see over on your left side corner, minimum value negative 10 and 10. How about for your y-axis? For your y-axis, you can start here, negative 13 to negative 5. Right? Negative 13 to 5. Then I have this question before. Some students ask, sir, I have a question. If I start from negative 12 here to negative 6 here, can it still work or not? Can it still recognize negative 13? All right, let's start from here. Let's say, let's do some example. Let's start from negative 12 here. Obviously, I should start from there, but I'll start from here. See, can it still work or not? Maybe I'll stop to negative 6 lah. I'll stop to negative 6. All right, this 1e, negative 12, 1e, negative 6. And I choose lock, right? 1e negative, 1e 6. Okay, so how do I know it works or not? All right, so now already done it. Can you see the coordinates? Can you see the coordinates on your, this is very small, on your bottom right corner? Can you see the coordinates here or not? Yeah, this is the bottom right corner, down here, is over down here. If I move it to the end here, what it written here is about negative 10 to 1 e negative 30. So it's still recognized. Although just now, for my y-axis, I only start from negative 12 to 6. When I put over here, in fact, when I put outside this plot here, you still recognize. You see, all the values that you put here, even outside the plots, you still recognize as a data point. So it means that the software is very flexible. So sometimes the graph, I've seen some journal paper, they don't have this value here. They don't have this value here. They start something in between. You can use that. Okay, we're done right now. So the feature right now, do you want to see automatic or manual? Asking, do you want to see automatic or manual?
Manual. Try manual.
You want to see manual? Okay. All right. So to do manual is easy. All right. We're done already. X and Y, we're done already. We do manual first. You click manual. Okay. So this is how you click. There. Can you see? So you say that, sir, how accurate it is? It is how you click lah. Yeah, suddenly, if you click like that, of course, obviously, it's not going to be accurate anymore lah. So it's how meticulous or how details are you. So, oh, they did a mistake here. What do I do? You just delete it. Go ahead, delete. Yeah, you delete the data point here. As easy as that. Okay, so I'm just clicking here. Okay, let me make a mistake for you lah. So I'm clicking here suddenly, and then this part I suddenly put on top here lah. Let's say I do it like that. Then I forgot about it. You know, maybe I forgot about it. I did everything done here. Oh, done. Click first. Click. Very simple. Just clicking here only. Data done. Clicking up and down. Okay, I done that. Okay, I click everything already. Then I say, okay, click to end series. Okay, so I already got my data point. But then after that, I found, hey, I did a mistake just now. Oh, what can I do? I did a mistake here. Oh, should I do it again? No. Just press here, select and move a node. Okay, just press this sign here. You see? Move it back. That's easy. See, so easy. So since, let's see, like if you make a mistake earlier on, you say that, oh, I did a mistake. I should have, I just want to adjust this part here to go to here. You can adjust. You adjust manually. Adjust the part here, go down here. Right. Very flexible. All right. You done that. Now the next thing you do, you go to the next step, the graph data, or done. See, you already got the graph. As easy as that. I just double click. You already got the graph here. If you want to use the graph here, let's say like if you're fast, you want to use the graph, maybe not for journal paper lah, maybe just to reporting to your supervisor. I got this graph. I don't want to use MATLAB. Yeah, you can use here. You can edit the title, y-axis. What is the axis name here? Source drain current. Source drain current. Okay, just go to here and just label it source drain. See, as easy as that. And then what is your graph data here? Gate voltage. Okay, gate voltage. Gate voltage. Okay. And how about you can do many things with legend. You want tin. This is the legend here, the series here. Sometimes you don't like the name called series here, right? So what is actually is called VDS 1000 MV. Can we change that? Yeah. VDS. And then you say it doesn't change that, you have to click back here. Change. How come it doesn't change, huh? Change back here. Let me see, huh? Go back here. Yeah, already changed here. So, which means that sometimes it doesn't update. What you do is that instead of clicking all this part here, it doesn't update. You just go back to the data point and then you go back to the graph. Then it's already updated for you. And the series, what color do you want? If you want to have it, let's see what color. I choose pink just now, and you choose pink here, change color and choose any pink color that you like. You already got it there. If you want to change it to rectangular, any form you got. And you already done it, and you say, I'm happy with it. I want to export it as an image, and this export. Okay, export it as a PNG file. We just type it example1 ex1, and then we open the figure. We open the figure. There you go. Oh, obviously I need to share it in open with. You cannot see it now. I know. There, you already got a figure. As easy as that lah. So this is not using MATLAB. This is using the software itself. But if you want to use MATLAB, how do you do it? Okay, all right. Let's see an example. How do you use MATLAB? So if you want to plot it in MATLAB, what next thing you do is that you grab data, you say export as a data file. Okay, export it as a data file. All right, digitizing example. Obviously, you can name it as any name you want. So the reason is that I name it as experiment data, any name lah, data.csv. It has to be CSV file lah. Normally when you save it, it's a CSV file. So I already save it. I don't want to overwrite my file. Maybe I put 456 lah. Okay, then we go back to PGSS over here. Then we open our CSV file. All right, there you go, the X1. This is the important thing. Anything that you do, you want to get this X and Y. Because by getting this X and Y, then you can plot your graph. Okay, I'm getting the X and Y. Next thing you do, you open your MATLAB. Okay, let's open my MATLAB. And then I open main one. Oh, this one is the complicated one. We have a more simpler one, not main 3. Oh, no. Okay lah. So I have to make it simple lah. Okay, what I do is that let me save this code first for where's the save button You open too much file already, you forgot already. Yeah, close this one first. Let me open, maximize it. There we go. Editor, save as, and save as the simple one, main lah, save as main. So the simple plot that you normally do is, just getting back to my PowerPoint. What did I write just now? Let's copy this line here, these 3 lines here. See, I just press F5. F5. There you go, that's the plot. You see, clear all, close all CLC is just a initialization, means that clear all this, remove all this data. So the important thing is these 3 lines here only. All right, let me zoom in closer. Oh, can't really zoom in anymore. So the most important is this 3 line. You get your CSV file, you read the table. So it becomes a table, and then you change it to array, and then you plot the first. Obviously, you have to know some basic on MATLAB. This is what the column means, which means that take the first column. Then what is the column mean? The column means that all the, which means that take the first column, and then the column which means that all the rows. What row? Is it until 73 or what? You say take until finish the data. So until row 73 lah. That's what I mean. And then after that, plot take the column number 2. Take column number 1 versus column number 2. Look at the sign here. This A here. Take column number 1, plot column number 2. Then you run it, press F5, and you get the graph here. All right, you get the graph here. I need to get a simple one. Don't worry, I'll share all the code with you. I'll share with everyone all the codes, and then we go just run a more complicated one, the main one. All right, this is a much more complicated curve. So when I run it, look at this curve here, and this one I run 2 codes. I got main 1 and main 2. What's the difference between main 1 and main 2? The difference between main 1 and main 2 is that the main 2 has more. Let me see. Yeah, main 1 and main 2. What's the difference? Opening bigger and bigger. You see that main 2 has more dots, more dots, and main 1 has less dot. All right. So how do you get high quality curve from here? All right. So common mistake that students normally do. Common mistake. What they do? They just save file, save as. Okay, I just they do it like this, file save as, and then okay lah. Maybe I want to get a better one. You can choose PDF or what lah. Normally, if you choose JPEG lah, okay, let's say I'm doing it right here with you. I'm doing here figure1.jpg. Save it. Okay, I'm figure 1 JPEG. Save it. All right. I have to open a Word file right now, and I have to share with you. Okay, let me share my Word file with you first, so at least you can see what I'm doing. So you're writing a paper. Normally, paper is in Word file. Share content. I'm going to share my Word file. All right. I'm going to open new one. Okay. Open new one. Everybody can see my. Okay. Then you obviously that's how you do it. Insert this figure here, and you get your. Okay. Let's look at my figure just now. Okay, this is my figure that I get, right? Okay. So far from outside, from here it looks clear. From here it looks okay. Then normally when you submit to journal paper, they say that, okay, you have to create a PDF, right? Okay, I'm going to create a PDF. Say I print as a PDF. Let me select my PDF, Adobe PDF. Obviously PDF here, I select high quality print. I select high quality, everything high quality, A4 here, size here. I'm going to print, press OK. I'm going to print here. It's already high quality. It's printing right now. It's printing right now. I'll go to my desktop. I put document 1. I say okay. All right, it's printing right now. All right, I got the PDF right now. Okay, I got my PDF right now. Then you say it's high quality, right? Let's say it's a high quality or not. So let's start zooming in. Zoom. See, it's not high quality at all. You see all this pixelation. You look at all these things. Oh, not high quality. It looks a bit blurred here. Yeah, doesn't look good at all. You see all this color here, not crisp lah. So what have you done wrong? What have you done wrong? How do we fix this problem? How do we get high quality? Easy, huh? So let's get back to MATLAB. Let's get back to MATLAB and we solve the problem, huh? Okay, let me minimize this and getting back to MATLAB. All right, in MATLAB just now, okay, this is figure 1 and this figure 2 here. So what you do, most important thing is you go to here, you go to edit, you copy figure. That's all. Edit, copy figure. That's it. Edit, copy figure, go back to your Word file. Go down here, paste it here. All right, I'm going to go there, go here, paste it here. But obviously now you cannot see which one high quality, right? Never mind. We print as a PDF again. Print as a PDF, and then we compare. Desktop, and we create document 2 lah. We create a PDF for document 2. I'm creating the PDF right now. Okay, this is the first figure that we did by using the JPEG insert. And let's go to the second curve here. And this is what we did using copy figure, edit copy figure, and paste. Let's look at it, how clear it is. This is how you do it. Super clear. And this is where journal paper, publisher, editor see your figure and say, "Ooh, high quality." You know, some journal paper, even Movement send, we send it outside. They say, "Oh, your figure looks very bad. Oh, please pay $100. We improve it for you." And then they say that if you don't want to pay $100, it's okay. Then they keep rejecting your figure. They say that, oh, then they say you redo again. Make sure your figure high quality. Then you redo, you submit to them. They say, oh, you didn't fulfill the requirement. Not 300 dots per inch or what, the DPI, the resolution not clear. Do you still want to pay $100 to upgrade it? We do it for you. No, you do it in MATLAB. You do it yourself. Copy, edit figure. All right, look at this figure. This figure is so huge, right? So the mistake that normally many people do is that even you get this figure here, is high quality, you say, oh, it's too big lah. You shrink it like that. Don't do that, okay? Because if you shrink it from Word here, what happened? Everything looks tiny, small. So if you want to shrink anything, go to your MATLAB and shrink it here. Because if you shrink it here, your words, your axis looks okay. The font size still looks good. All right, let me adjust it more. I'm doing it like this, edit, copy figure, and I'll paste it here in my Word file. Okay, can see the differences. So anything that you want to do it in MATLAB. All right, edit, resize it in MATLAB. What is the next step you do? Resize it properly, make sure you're happy with it, or like that, some curve like that. Edit, copy figure. Okay, another tips for you. Let's say that you save this file and then you don't want to run the code again. All right, you already saved this file, right? Let's say that you run a MATLAB simulation, takes about 40 minutes to get the curve. Then after that, you already got the figure, you forgot about it. Then you say, oh, I want to adjust because it shouldn't be like this. I want to adjust, but you found out that you do want to run the code again. So you save it as MATLAB figure file. You say MATLAB figure file, f.fig here. You save it as figure 2. So anytime, all right, let me close the figure. Let me close everything here. I'm closing the figure. And you want to call back your figure without running the script. So you just go to open. All right, you just go back to here, figure 2, and you already got your figure back. All right, so maybe make it a practice. If you do MATLAB, save it as a fig file, so that anytime if you want to adjust something, you can do it nicely. Okay, so MATLAB is okay right now. Let's get back to the curve design, because I just want to show you how to do it automatically. Let's get back to there. Okay, let's get back to this curve here. All right, we already done this thing, and okay, we are done. We are happy with it. We want to do a new data series. All right, we already done this data series. We want to do the second one automatically. All right, so what you do is you say add automatically, and then let's pick the second curve here. This is how you say that you're masking. How do you want it? You say thin here. I see. I just run it across it. So a good thing about this, they can recognize color. All right. So I'm putting here, going up here, down here, down here, down here, down here. Your mask is done. You say, okay, my mask is done. Okay, you say, okay, now you will create a series based on your mask. And you can see the blue right now, right? The blue line. it's quite accurate. You say, look at the blue line here. So if you say that, okay, I want more high sensitivity apply, all right, then it looks even better. Let's say if I want low sensitivity, all right, then a lot of rough edges lah, up and down, up and down. If you choose higher threshold, what I see here is a bit smooth lah. All right, okay, I'm choosing this one. I say accept, and then do you want less point? You see, if I choose less point, what here? It doesn't become so accurate anymore lah. So I say I want more points. It's okay, I want more points. Accept. And you can adjust yourself later on lah. You can adjust, okay, I want to adjust this point here. I want to adjust that point here. That's how you do it. And once you're done, you just go to graph data. You already got your second line here. Okay, you already got your second line. You say one line, two lines. So easy. If you do another one, I say, okay, I want to do the third one right now. I want to add automatically right now. I want to do the third one. Do the blue line here. Go up and down. The blue line, go up, down. Okay, I'm happy with it. I click my mouse is done. I say yes. And then threshold, just play around with the threshold. I say, okay, apply the threshold. I'm happy with the threshold. Accept, and go to the next graph. You already got your third line. As easy as that. Less than 5 minutes, you can go get all the graph. And you get the graph here. You can, next thing you do, you got all the data series here, right? So then you export as a data file. So you're going to have, I'm going to save it as A here. File open, browse. I'm going to save as A here. Let's see, where is it? Oh, because it's a CSV file, I have to I go to the open the CSV file. Oh, what happened? It's not opening. Is it opening here? No. Right, see. This is the first plot that I got. And then that is the second plot that I get just now. And that is the third series. Okay, so the thing that I want to point out here, when you do the first series, second series, and third series, you cannot actually plot it in MATLAB anymore, because when you plot in MATLAB, it will overlap, it will overlap again. Because when you plot the first curve here, suddenly you will overlap with these two things here. So if you want to plot in MATLAB, my suggestion would be, if you want to do it, all right, maybe you cut it and you paste it in different, you manually change it like that lah. Then you can plot in MATLAB. Because later on, when you plot in MATLAB, what you do is say that plot the first column versus the second column, plot the fourth and fifth, and plot the fourth, fifth, sixth, seven, and eight. All right. Because if you just put everything down here, then it will not be nice lah. So the advantage that I see from this software is that when you put it in CSV file, instead of they putting it in column, they put everything in the same column 1 and 2, everything that you do. So my suggestion would be, you just go there and adjust it. Maybe after that, you save it again. You save it again. You're done with it. You save it again. You save it as B here. You save it as B here. All right. So let's go to MATLAB. Let's see if we can plot it or not. Let's go to my file just now. I open file. What did I save just now? What's the main? Okay. Is it this one? No. I'm going to get back my code here. Okay. Okay, this is the one that I saved just now, A1, A2, read table A1, A2. Okay. What's the name of the file? I say B, B as CSV. See, is it plotting anything or not? Okay, it's plotting something. Let me move it down a bit. Oh. Because the WebEx is taking it. I cannot. Oh, wait. Okay, I already taken it. Go to my MATLAB. The figure here. All right, you already got the figure here. But what if you want to add more rows here? Okay, just add more rows. Semilog, semilog. Put the word hold on. Hold on means that, wait, I want to add more curve. This is what it means by hold on, MATLAB. And then 1, 2, just how I say 4, 5, right? 1, 2, 3, 4, 5. And then there's no 6, and then there's 7, and is it 7 and 8? Back to the file. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, 7 and 8. Let's get back to my MATLAB file. Put this in here. There you go. See? MATLAB file. Oh my. Let me pull it down. The figure always go up. Okay, I'll put it down. Look at the figure. All right. So the tips here is make sure that what do you do just now? Make sure that you move it to sideways, and then just by having my code here, adjust a few lines, and you can do it. So this is the line just now. If I edit here, if I go to my main one here, all right, it's the same thing lah. If I want to do it here, I just say that example 1 and 2, and then after that, hold on, example 3 and 4 and 5 and 6 like that lah. Let's see here. If I want to do it here, how do I do it? Okay, this is the curve here, right? If let's say like if I want to do it here, and if you are curious lah, let's see if I can do it or not lah. If I want to edit this code to include these three things here, okay. So you just put B here, change it to B. Okay, on this part here, let me change it to, I don't want, because I already say on diamonds here, because color, let me change the color first. All right, 1, 2, then is actually 4, 5, right? 1, 2, 4, 5, and then 7 and 8. Hopefully it works. Let's see, does it work or not? Oh, not working. You only got, oh, of course it's not working lah, because I forgot to put hold on. Hold on, which means that, wait, I want to plot another graph. Let's check again. Hopefully it works. There you go. There you go. All the three curve there. Right? So MATLAB is very simple. You got all the three curve here. Then this is what I'm telling you. So when you look at the curve here, the way you click it determines the curve here. And you will see some part here that you have empty region. Empty, right? You say, oh, this part is empty here, this part is empty there. So what do you do to make sure that all the line is filled? There's no empty space here. Then you can go to my main tool here, and you can add this line called interpolation, interpolate here. And when you add these two lines here, then it will be much better. I don't think we have enough time to go to this interpolation, but I'll just stop it here first. I'm just showing here I'll give you the MATLAB script, everything you do. So what you do here is that you have to have some understanding of MATLAB, then you just simply modify for my code. My code I've written very nice already. You can modify it, add that, and you get better. Let's look again. Oh, let's look at all these cover. Oh, looks very nice. Oh, looks, yeah, adjust it here, adjust it there. Okay, let me show you one thing. Let me show you one thing before we go. Let me, do I have, oh, I don't have it here. Do I have it here or not? Okay. So let me just explain to you. When you choose a color, right, for your MATLAB figure, it is important to choose color that is quite distinctive. So for example here, when I choose this color here, I say that perhaps you look at the pink color and the blue color, very good color. And look at the cyan color, it's like a light blue, not a good color. Right? When you put in a figure here, it looks a bit blurry. So how do you choose a color? Last time I used to write a MATLAB script that automatically can choose color for you, which means that if you have eight, let's say you have 8 curve here, and it will choose 8 color for you that is distinctive, which means that when you look at it, your eyes will say, wow, this one very bright and very clear. So, but I didn't put it here, the software. I didn't put it my code here. So that is why it doesn't appear here. So what I meant is like publish paper, maybe look at one of my paper here. Okay, like this one. when I do not choose, when I do not define my color, MATLAB will choose the color for me. And sometimes I get the color like green color here, this three color. All right, maybe for three colors is okay. Maybe if you have 8 curve like that, or a lot of curve here, and you can see that this is not a good color, the purple, the light purple is not a good color because it's not so clear. So that software, that script will help you to get the color automatically yourself, and then they choose the color for you. All right. So with that, I think I already completed everything that you have to know from your digitizing software. If you have any question, you can just ask down here and I'll try to help you. Okay. Any question you want to ask about the software before we end the session? Because I already show you many things already from the beginning, how to do manually, how to do automatically, how do you plot it in MATLAB, and how do you get high resolution curve in MATLAB when you copy and paste it. Again, like I told you, if you do not have any fundamental in MATLAB, you need to learn it because it's quite useful. Because for my PhD as well, even for my master, last time I'm not really good in MATLAB. I learned everything by myself. And I can tell you that plotting is not difficult because once you got the template, like the M script that I show you, you just adjust it from there. Okay, adjust it. Like you just have to know what is all this meaning here. What is dash dash D here? Dash dash D. What's the meaning of dash dash D? Dash dash means that if you look at the line here, is actually dash line. If I just remove one dash here and I run again the software, and run again, run again, close it and run again. Now you look at it. Oh, now you look at it. See the line here? It becomes solid line. It becomes solid line, right? As simple as that. When I change this one, this D stands for diamond. I put 0 here. I put O here. I put O here. Let me put O here, and then let me put K. I'm not too sure. Is this line? I put plus line here, and I close it and run again in MATLAB. Usually my MATLAB is very fast, 3 seconds, but today because opening a lot of software, it becomes very slow. And look at it now. There's diamond here. There's circle and there's plus sign. Okay, get it. Very nice. Okay, let's say that you are not quite good at editing the codes from here. You say I'm not sure. You can actually edit it from edit plots to edit plots here. Just double click anything you want. Double click here, double click that. There, the property inspector will come out, and then they'll show you how to do it. Oh, how come there? You see, I want to change it into different the location of this legend. I want to put it east. East here. I want to put it north, south, up here. Very a lot of features here. You want to put it outside, you want to put inside, you want to put different color, you want to change the name here. Label experiment data, I want to put it at 100 MBS here. Okay, press enter. Okay, change here. So there are 2 ways to do it. All right, you can actually do it manually by going to the property inspector, edit one by one. But usually for my student, I'll recommend them to type it in a code because when you type it in the code, it's very easy. One time you press the run, everything you make it into a nice template for you. If you were to do it manually, it'll take some time. So I got a question here. Doctor, can you show us again the part of the code, how to you are reading Excel and choosing the column to plot? Oh, very easy. So which means that you're asking here, okay, all right, when you save it as a data file, you get it in this different column here. All right, so you get 1, 2, 3, 4, 5, 6. Let's say that if you want to put near to each other, you can. How do you want to put it? It's okay. I'm just putting the gap here. Let's say I want to put it this one, I'll put it like that here, and I'll put it like that. I'll put it side by side. Then you just save it. I'm just save it. Okay. So next thing I have to do is I have to go back to my MATLAB coding here. All right. This is my MATLAB coding, and this you have to change because I say 1, 2, then it becomes 3, 4 already, right? So it becomes, what it means here is that for the first curve, your X and Y you take from the column A and column B, your X and Y. And the second one, the second curve, take from the column B, C and D lah. Obviously in MATLAB, you don't write it C and D, you write 3 and 4 because this is column number 3, number 4, number 5, number 6. Okay, getting back to MATLAB here, so 1, 2, 3, 4, 5, and 6. Okay, save it, press F5. Can it run or not? Let's see, it's appearing or not. There you go. It can. What if you do some mistake? Let's say if I, instead of 6 here, I put 8 I know that there's no 8 there. Can it plot or not? It can plot. It can plot only the first two. It cannot plot the other one because there's nothing there. All right. If you look at your, so it's very important to see. Sometimes it doesn't give you error. It just doesn't plot. All right. If I'm putting it nicely now, and you get the curve, all the curve here. Let me explain to you the script again. So when you get a CSV file, how do you tell MATLAB, like, okay, I have this CSV file, import it into MATLAB. So that is function that I read. It's called read table. So read table, which means that get the CSV file, b.csv file, get it, and you have to put it somewhere. Put it in T. So I say put it in T. I have to put it somewhere, or not, you have to store it somewhere. So I put it in T here. Let me see the, put it in T. If I open my MATLAB again, how do I view the default view? Layout. Maybe I put all the default. I have to go back to default. Okay. I run this one. See, got error or not? There's no error here. Very important to show you this one. All right. So now when I import it in MATLAB, you get a table. All right. You get the table. When you double click the table here, this one, when you double click this workspace here, you get the table here. And usually table, it looks exactly like a CSV file, but you cannot plot it from the table. You need to take it out. You need to take it out from the table. It's already stored inside MATLAB, but in order to plot it, you need to convert it into double. That's in MATLAB, they call double here. So that is why I say that, okay, now I know that you are in table. I want to change the table just now into array, which means that into array, which means example 1. So when I change it into array in example 1, now you can select it yourself. It's not a table anymore. It's something like in MATLAB In MATLAB, you're having array of data, multiple data in one workspace. Say for example 1, you get it and you can start plotting it. So that is how you import it in MATLAB, and by using simple code here, simple code. Okay. Is there any option for GrabGrabber to assign exits in time series? Let's say that you want to grab exit in 12 months. Or what can tell you that GrabGrabber is, I don't think in time they're able to do that. Maybe what you have to do is that you have to manually edit it in CSV file. Once you get the CSV file, all right, let's say if you click it nicely, perhaps you have to convert it yourself over here because I haven't plotted in time series before. Like if it's in second, it's just easy 0, 1, 2, 3, 4, 5 second is straightforward. If it's a date like 12 April and then 13 April, 14 April, which means that you need to do something, which means that you can, maybe the code, you have to add extra code, or maybe you have to edit somewhere there. Then you can plot it in. I'm sure that there's a way to do it, which means that it's just not straightforward. You need to do something first, then you can plot it in. All right, so it's how to do it. Okay, how to do time series? You just go Google first. You say that there's a lot of help out there. Say I want to plot MATLAB in time series, and they will show you how do you plot time series. Okay, okay. Any more question? Oh, if you introduce interpolation, right? Okay, it's very simple. Interpolation, you can decide yourself. All right, you see, what my interpolation here, this is the code that I use here. So the interpolation, I say that from -10 to 10, this is now the curve here, every 0.2 create a data point. every 0.2, which means that negative 9.8, negative 9.6, negative 9.4. If you want to, no, I say that, oh, that's too near. I want bigger. Then you change lah. Okay, every 0.5, create a data. It's easy as that. Or every 0.01, create data. Right? So you determine, Andika, you determine how precise or how near your interpolation you want. All right. There's the code here. Interpolation, there's one code here. So when this interpolation, you can read more about this function here. Interpolation, you can do linear, you can do many lah. So it's up to you. You can read this function here. They'll tell you all this. I choose linear here lah. Just one example here. And this is how precise or how much data point you want. Okay, any more? Is it question on MATLAB? Can help you. I know a lot of things on this tweaking here. And you can ask Moven as well. Moven is also very expert. He's also the PGSS vice president. He knows a lot. He do a lot of plotting as well. Okay, so we already know this code here, the code there. Many example here. Usually when I these all the codes here. One MATLAB, digitizing software. These are my other software that I used before lah. Replica. I used to use this one Replica software, but they don't have this automatic function. And then another one got the get data graph digitizer. Let me see if I get any more things to add to you. Let me think. Let me find my MATLAB or something. Plotting high quality, yeah. If I have any question, you can ask me lah. Let me go find some. If I have supplement data. Quality plots. Oh, don't have already. Not many file here. Need. I'm trying to open up my CPU is running maximum already, so it's a bit slow already. Opening too many PDF file. Close some PDF file first. How do we define the mask? Oh, the mask is define the mask. Yeah, just press this one. Mask thickness. You only can choose 3 only. Thin, medium, and thick. How do we define a mask? This automatically and select mask. Automatically, then the mask will appear. Okay. More here, digitizing. My lesson, let's see, anything. Yeah, this is some of the example that I used to do a workshop. Last time I used to do for this company. And these are the example. Last time I did my, you have question, what is actually interpolation? I don't know what is that. This is what it means before interpolation and after interpolation. You see, you got all these white spaces and gap here, right? So just a simple code after interpolation, you see that all is actually uniform. Very nice, uniform. So here's one example. This is the one that I'm telling you about. How to create maximally perceptually distinct color by using this function file. This is called a function file distinguishable underscore color.m. You can get it in, I think, the MATLAB file exchange, Brad Shoden. What do you mean here? By using a simple code here, let's say I've got how many curves here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 curves here. All the colors looks very easy to distinguish. Right? Look here, right? Very easy to distinguish. They automatically create the color for you. And these are the one that we did just now, interpolation, all this color here. And I teach you how to do the inside as well. You got 2 curves here, you put 1 curve inside here, and that's it. Okay, I'm familiar with MATLAB. Best estimate is a function of toolbox developed by MATLAB and MATLAB exchange file that having similar. All right, so I did come across some MATLAB function, MATLAB digitizing example, but then they haven't been updated it many years already. I see that. So I'm not comfortable using that kind of toolbox by that person that developed. So I would prefer to use this graph grabber. And in fact, honestly, I can tell you, I just found this software maybe 2 weeks ago only. Because previously I'm not using this software, I'm using another software which is also freeware, but the software does not give you automatic detection, and they don't have this automatic plot here. So now I'm giving you the best software that I found, updated already, even for Windows 10, because all the other software that I found before, maybe Windows, older version of Windows, these are the latest one, and I do recommend that. And even if you go to YouTube as well, you can find some software. Origin also do enable digitizing as well. But then I'm also familiar with Origin. I'm much more comfortable with MATLAB and this software. Okay. Any more question? Okay, so all right. So with that, I think I've done everything that I can to share my knowledge with you. Hopefully you can find it beneficial. Again, if you need all the data file, I'll try to provide it to the PGSS, and then maybe they can share with you. All right. Okay, thank you. Okay, Mansi,
Yeah.
yeah.
Okay, doctor, I think we still have some 2 more questions.
Okay.
Yeah, all right. So there's a question, doctor, if you refer to the Excel file extracted, and we see the first X value is 10 point something, negative 10 point something, but while in the graph, the minimum one is negative 10. So does that affect the accuracy of the extracted data?
Oh, because I explained earlier on, it's not the fault of the data. It's actually accurate. Because it can get negative 10. Let me share with you again. The software itself. Where is it? Did I close the software already? Graph data. Okay, graph data. I'm going to share the software with you. So if you look at the software itself, right? When I want to get any data, let's say I want to get the data memory, right? Even though I set negative 10 to 10 over here, when I click here, there is a data point. This data point, which means that anywhere between there, because it's the way I click, right? Because it's not when I click here, I click at the back. So it is so accurate, even if I click further back, it can know that it is beyond negative 10. So it's not the accuracy issue, is because it is so precise. So there's no problem with that. Okay, I hope that answer your question. There's no problem with the software itself. It's just that how we click it.
Okay, doctor. So we have another question from Zohai. And doctor, how we can plot data automatically? As manually, we made some point of the graph. So how exactly we can extract the graph data points?
So it means that how do we do automatically? Yeah, just now how to do automatically as easy as this one. You want to do automatically, first of all, you just click here, add data series automatically. and then just do a masking. Let's say I'm doing the black one, I'm doing the masking here, up and down, then go up here, down here, and then maybe I'll just go in the end. Then you're done. You say complete is done. Say yes. That's how you do it. Then I get the data already for the black color. You can see here, I'm just adjusting the threshold. And I say accept. Then I get the green line. Can you see the green line there? Then when I go here, I got the green plot. Okay. So that's how you do it automatically. You just have to say add data stream automatically and then select the mask and just run the mask across -10 to 10, click enter, and then you got the graph.
Okay, so thank you, Doctor. I think there's no more question. So thank you very much to our speaker of the day, Associate Professor, TSIR Dr. Michael Tan Long Peng. And it is a very informative and concise presentation. We have learned a lot of things, like how to extract the graph from figures and how to plot them in MATLAB to get high quality graphs. And thank you, Doctor, again for your time to share the knowledge. And it was a pleasure to have you with us. And yeah, thank you, Doctor. So for the participants, be sure to fill in the feedback form and please enter the correct details because we will use the details to record your attendance and issue an e-certificate to you and email the slide to you. So be sure to fill in the correct details. And now we are going to have a group photo session with the participants. So dear participants, please turn your video on. We are going to have a group photo session. Okay, more participants, kindly turn on your video. Okay, so ready? 3, 2, 1, smile. Let me take a screenshot. Okay, one more. 3, 2, 1. Okay, I think I got it. So, okay. So once again, thank you, Doctor. And Doctor, you may leave the session early now if you want, and the committee will contact you after this. So thank you very much, Doctor.
All right, thank you, Manseng. If anyone have any more question, if you want you can feel free to email me, and I'll try to help you and answer your query lah. All right, thank you, everyone.
Okay, thank you, Doctor. And for the participants, we have some announcements. So please fill in the feedback form. And the link is in the chat window. Let me share my slide. Okay, so please fill in the feedback form. So the link is in the chat window, or you may scan the QR code on the slide and it will direct you to the Google form. So for UTM participants, noted that we will use the feedback form to record your attendance. And we will record your attendance in the UTM archive system and issue an e-certificate for you through the email. So be sure to fill in the correct details. And we will share the slides once we get we get the slide from Dr. And thank you very much. And so see you in the coming workshops. Thank you again for joining us today. So stay safe and healthy. Have a good day.